Hello. Good afternoon, all of you, all dignitaries, respected professors and students. Myself, Ketan Khamgaonkar. So they already introduced me. So I have done my BTech from College of Engineering, Pune, and MTech from IIT Roorkee. I was a research scholar at IIT Bombay. I left it and I have started my startup called as Parenthesis Labs. So it is a remote startup. Basically, we work on artificial intelligence, web development, app development, things like this. So on this note, let's get started with my topic today, which is artificial intelligence in healthcare. So what are the objectives of today's session? So the objectives are why machine learning in healthcare is so important. Second thing is concepts and principles of machine learning in healthcare. Third is the evaluation matrices. So once you have used machine learning on on one of your problem, you need to evaluate how the model is performing. So that is the third. Fourth, there are a lot of challenges in machine learning as far as healthcare sector is concerned. So we will address some of them. And finally, you will be able to start your machine learning journey here onwards. So the topics that I will be covering in today's session are as follows. First is the definition. So a lot of you must have heard artificial intelligence, machine learning, and interchangeably people are using these terms to depict something. So we'll discuss on that. Second is the application of AI in day-to-day life. So it has artificial intelligence has already penetrated deeply in our day-to-day life. Lot of apps we are using. Google search engine itself, we will cover some of them. Then history of AI in healthcare. What is the history of AI in healthcare? Then fifth one is the important concepts and terms. So you need to understand certain terms and concepts so that we understand the terminology and the jargon of machine learning basically. Finally, how machine learning works and challenges of machine learning in healthcare. So, what is the difference between artificial intelligence and machine learning? A lot of people are using this term interchangeably. Basically, they mean the same thing. Machine learning is a term which is more used by data scientists or scientists who are working deeply in machine learning. People like, for common people like us, AI is the term used to tell the same thing. So, it is basically one and the same thing. For marketing purposes, AI is basically used. So AI refers to the development of machine capabilities. So next, what is machine learning? So I have three definitions for machine learning. First one is the most technical one. So what is machine learning? It is a family of statistical and mathematical modeling techniques. Family of statistical mathematics that uses a variety of approaches to automatically learn. So a lot of algorithms they have created. So basically by using them, they automatically learn to solve a problem and improve the target state, improve the performance of our algorithm without explicit programming. So basically, we are not programming anything. We are just giving a set of algorithm or defining a set of algorithm. We will give it to the computer and it will come up with the model to solve the issue. The easier one, more easier than this is systems that improve their performance with exposure to more and more data. So as we expose our models or artificial algorithms to artificial learning algorithms to more and more data, their performance keeps on increasing. And the most easiest one is machine learning involves development of computer algorithms to perform tasks typically associated with human intelligence. So, human intelligence, like we have vision, we see text, we summarize the text, we want some information collected from the text. Computer by itself is not able to analyze if we give some random text to it. If we show them random images, it is not able to identify if it is a cat or if it is a dog. So, giving these capabilities, basically mimicking the brain, the working of brain, is what the ultimate aim of artificial intelligence or machine learning is. Next slide. So, what is the difference between normal computer programming and machine learning? So, computer programming we are using since a long time, long duration. Why we need to define a new term called as machine learning? Because in normal computer programming, we are giving some data, we are defining certain rules, and the computer will compute it and give the answers to us. But in machine learning, we are giving the answers as well as the data, and from it, it will map the rules. This is the difference between artificial intelligence and normal programming. So, in computer programming, we have a defined set of rules like y is equal to x square. We will define some rule, we will give x to it, it will keep on computing the y for us. So, we will define some function, based on it, it will keep on computing. But in machine learning, we have a defined data, we give a defined output. Like in medical, I saw some examples like ECG they are giving, ECG data, and the answer is if the person ECG whose ECG was taken, he has undergone heart attack or not, yes or no. So basically we are giving the input and output, the algorithm will come up with the answer for mapping the input to the output. So sometimes these models or these functions can be too complex, so we keep it on the computer to map the inputs to the outputs. So what are the examples of AI in day-to-day life? So we have smart voice assistants like Siri, Alexa, Google Assistant. These are all based on machine learning, artificial intelligence. Social media feeds. Our social media feeds like Google, sometimes Google search engine also gives a certain search advertisement to us. Facebook, Twitter feeds, everything is based on artificial intelligence. Self-driving cars, Tesla. So it can detect at how much distance a certain car is, at if there are some animals standing there, what is the signal. So this is all based on computer vision, Tesla cars. Then YouTube recommendations based on AI, Amazon recommendation, Netflix recommendation. If you see a certain movie, you see a lot of recommendations shown to you. These are based on artificial intelligence. Google Lens, I have shown some images of Google Lens. If you take a photograph of some flower or some petal, it will tell the species or some details about it. Speech to text, like if I am talking something, it will transcribe it to a text. This is based on artificial intelligence. Transcription, subtitles on live. If something is live streaming, it will give the subtitles simultaneously. Video, translations, live translation it will give. If I am talking in English, it will give in Marathi or Hindi or vice versa. Google search again is based on artificial intelligence. Auto-completion of sentences. Sometimes we are typing and we see auto-completion in our mail based on AI. Grammar correction again, the same thing. So we are using AI in almost everyday life. So application of AI in a lot of sectors is there. I have named the sectors basically: automobile, finance, e-commerce, marketing, social media, entertainment, space research, earth sciences, robotics. Everywhere, almost everywhere it is being used. Education, gaming, healthcare. These are all the sectors. So what are the recent advances of AI in healthcare? So I have named certain advances. Lot of research is being done. So it can be used in personalized healthcare, like precision medicine for studying a person's medical history. It can tell the precise medicinal requirements for that person. Patient risk stratification, it can stratify the patients based on who are at high risk, who are at lower risk, etc. Better protocol and strategies. We can study a particular disease as well, study a data on them in a particular strata of society or section of society and come up with better protocols for them. Image analysis, I have already told you. Image analysis is the most commonly used thing. It has been increased day by day. The applications are increasing, like analyzing radiology, pathology images, classify high volumes of images quickly, detecting cancer in mammograms or applications like this. Drug development, effective drug development, then predictive modeling and health policies, predicting population at risk. So you can do a lot of predictive studies using machine learning. drug delivery, lot of applications are there. Basic biomedical research, autism diagnostics. So based on a child's eye movement, they are tracking a child's eye movement, and based on it, they are able to tell if he is autistic or not. Automated screening, diagnostics, home health wearables, IoT devices. These are being used every day. Patient-facing tools like chatbots for telehealth, mental health and wellness support applications are there. So basically, you can come and chat with them, ask your questions, and they will automatically answer based on the voice assistant. Basically, based on a similar technique like Alexa or Siri, they can be used in healthcare as well. So these are the recent examples. Then history of AI in healthcare. So the actual research started in 1970s. Stanford started a program in 1970s, the first program called as SUMEX AIM project. But after that, there was a plateau. So the research did not pick up after that because the complex algorithms were not developed until then. The hardware, GPUs, graphical processing unit required to do this much of computation to analyze huge amount of data was not present at that time. So right now there is a lot of increase, like I have shown the graph. The publications in AI in healthcare are increasing day by day because we have complex algorithms now to address these complicated issues which are in healthcare, as well as the hardware required to process the huge amount of data. So why machine learning in healthcare? Why should we use machine learning in healthcare? Because we can enhance the patient care delivery, enhance healthcare provider decision making processes. We can help them. There is lot of data which is being generated in healthcare sector. So this overwhelming amount of data can be difficult to process. So for a particular disease or for a particular person, we can come up with better protocols, better strategies to work on a disease or individual patients. The guidelines can be better here onwards. Prioritize clinical action needed for a patient. AI can tackle this mundane, tedious tasks like daily entry administrative task, improving information management, basically data analytics. Then it can help in early detection. Early detection, if there are chances of, if we can prevent someone getting admitted, we can address his, based on certain data, if we can stop taking him to the critical condition, that can be very helpful. So early detection and improving patient outcomes. So basically, this is also science of predictions, AI and community health, so it can be used there. Prediction of occurrence of diseases, risk assessment of individuals, you can stratify them, and high risk can be addressed first, in the first hand. So now we will start with some jargon, some terms in which we need to understand so that when we go deeper into machine learning, understand some things, it is easier for us to get into it. So what are algorithms? Algorithms are mathematical techniques developed by a statistician or mathematician to address a certain task. This is the definition of algorithm. Already we have discussed. An important term in machine learning is bias. So bias is the difference between the predicted and the expected value. So the machine learning algorithm will predict a certain value, and we have a certain value, a certain outcome of a certain like it can be like I told you, like ECG data, or it can be I saw an example of they have taken the size of tumors, and based on the size of tumor they have classified it as malignant or benign. So our algorithm should tell us exactly if the tumor is malignant or benign. If it is not telling us exactly what the outcome is, then the bias comes into picture. So inability to capture the real relationship. So inability of the our model to capture the real answer, the expected answer, is what is called as bias. Then what are features? Features are whatever input we are giving. Like we are giving ECG inputs, we are giving the size of the tumor. Everything can be called as a feature. What is a model? Model is basically what the algorithm gives for a certain gives a certain list of parameters and fits our inputs to outputs. So this is called as a model. So it is a well-defined computation formed as a result of certain algorithm takes a set of values. So it takes a set of values, To fit our input to output, this is called as model. Label. So outputs are labels. Basically, like I was telling the tumor. The tumor is malignant or benign. That is our label. ECG, the heart attack, yes or no. That is called as label. So this is the machine learning terminology. Another term. Parameters. So what are parameters? Parameters are variables of a model. Lot of models are there. It has certain number of variables. This we will model fits these parameters basically. So the machine learning in the training process, what it will do, it will fit certain values to these variables. These are called as parameters, which are there in every algorithm. Then another additional theme is called as hyperparameters. Hyperparameters are said before starting the training process. There are certain things like there is lot of data. So we need the data to be divided into certain batches. The batch size can be a hyperparameter. Number of batches can be a hyperparameter. What is the learning rate? We will come understand what is learning rate. So that can be hyperparameters. So these are defined before the training process starts. Then what is training? Finding the ideal parameters. Finding the parameters such that the model fits perfectly to your problem. This is basically what is training. Then loss. Loss is the difference between the predicted and the expected value is called as loss. So how badly a model performs on a certain single prediction is what is loss. So aim of our training is to reduce the losses. We will discuss them further. What are losses? Then we have a lot of data. We need the data to be split into three parts. First is the training. Second is the validation. Third is the test set. So training is basically where we set the parameters for learning. So like I was discussing about something like tumor. We are having benign and malignant tumors. So we need to set the parameters so that the answer matches to the outputs. So training process basically learning. We allow the algorithm to learn the function and link the inputs to the outputs. This is called as training. Then validation. Upon training, we need to check if the model is performing correctly. So we check it on the validation, and if the validation is giving us error, we go again back to the training step. Finally is the test set. So basically the test set is something which is not shown to the algorithm or the computer. We are hidden it from it, and we will give the input and see if the correct answer, the model is correctly mapping the answers to it. Certain amount of data which is hidden from the algorithm. So there are three types of machine learning algorithm basically, depending upon what kind of data we provide to our computer. If the data is labeled, like if you are telling what is the question and what is the answer, like I was telling about the tumor, you are giving the size of tumor, and if the tumor is malignant or benign, we are giving input as well as the answer, then it is called as supervised learning. So we are supervising the learning process of the algorithm basically by telling this is the answer and this is the question. Unsupervised learning, we are giving random data. It is not labeled. We are giving the data to the computer continuously. It will learn by itself to map them and to categorize them or do classification of this data. Then third is reinforcement learning. So reinforcement learning is also similar to supervised learning. So gaming and all reinforcement learning is there. Like it will tell, basically it learns from trial and error based on the environment. It will see if the answer is correct or not, and it will keep on learning from it. That is reinforcement learning. So I have again listed the algorithms that are there, like classification, regression, clustering, supervised and unsupervised learning. So you can study all the algorithms. So how are the machine going to learn then? So I have already told you the label and label data. Like the label data can be the images of dogs, which are labeled as dogs. Cats are labeled as cats. And this is called as labeling of data. Like I was telling, the ECG data can be the input, and upon processing we will see the output, like the patient has undergone heart attack or no. So the ECG is the input, heart attack yes or no is the answer. This is labeled data basically. So input features can be a lot of things. We can give images. So images they can give outputs like if the lung nodule is there or not, skin cancer, knee arthritis, based on those images, medical images. It can be structured data like lab values, age, diagnostic codes. So the labels or the answers can be if the heart attack has occurred or not, sepsis, mortality, etc. Unstructured data like in the nursing notes or pathology reports, and the labels or the outcomes can be final diagnostic, stroke, appendicitis, etc. So basically these are inputs and outputs. Various inputs can be given. So label types, there are basically, if the labels are continuous or numerical, the answer is, the process is called as regression. If they are in categories, then it is called as classification problem. So we have classification like I was telling about the this thing, tumor thing. So if the tumor is malignant or benign is a classification problem. A BMI versus weight, that can be a regression problem because the labels are weight or BMI are continuous thing or real numbers. Then it is called as regression. So this is a linear regression. So in the linear regression, we have some random data, x and y axis, and regression if the output labels are continuous or real values, then it is called as regression. So loss is the difference. So I have shown in the red line. You can see the red line. The difference between the line that is best fit to represent the data or generalize the data is the line which is dotted line, regression best fit line. And the difference between the fitted line and the real value is called as the loss. Our aim is to reduce the loss as much as possible. So based on this, we will train the parameters. Parameters like here are y is equal to mx plus b. M and B are our parameters. We have to adjust the parameters in such a way that the losses are minimum. So training and the aim of training is to reduce the losses. So I have defined what is linear regression. Linear regression assumes the linear relationship between the dependent and the independent variable. If the input variable is only one, then it is called as simple linear regression. If it has more than one inputs, then it is called as multivariate linear regression. So I have just covered some linear regression. You don't need to understand everything deep into this, just to get an overview of it, because you can code this easily. You don't need to understand the deep maths. Only I am introducing you to what is working behind the scenes or behind these things. You just need to understand the terminology and the basic use cases of each algorithm. This is all of this will get coded for you, or we will have experts that will do this. So just try to understand as much as you can. Don't need to get stressed by this huge maths. So the linear regression generalized, I have defined that y is equal to c0, c1, x1. So lot of x can be there, independent variables. So this is the linear regression problem. X1 are our parameter, C1, C2, C0, are our parameters. So again I have told that the aim of linear regression is to find the best fit. This is why it is called as linear. If you only take two terms, neglect the terms after C0, C1, only we are taking two terms, then it comes a line. It becomes a line if we take C0 is equal to 3, C1 is equal to 2. The lines look like this. That is why it is called as linear regression, because finally it becomes a line. So if there are categories, we can use logistic regression. We cannot fit a straight line if we have categorical values. Like I have told, it is the size of tumor versus if it is abnormal or normal. So here we cannot fit linear regression. We have to fit sigmoid equation, sigmoid function to this. Based on that curve, it will give a S-shaped curve. It will give us the probability between 0 to 1 if the tumor is benign or malignant. So we have to decide a boundary, decide a value of probability below which the tumor is benign, above which it will be malignant. So this is called a decision boundary. So what are the steps in machine learning? So first step is to understand and define the problem. Second is to understand and identify the data. Third is to collect and prepare data, choosing an appropriate model, training a model. Sixth is evaluate. You have to evaluate the model. Tuning the parameters. Once you evaluate the model, you can tune the parameters. 9 is prediction. You see the predictions and finally you deploy the model. So you'll understand what are the steps. So basically first is the find the objectives. What problem you are going to address is the first step. Problem statement, ethical consideration you have to understand. Characteristics of the problem. Data feasibility, economic feasibility. Everything you need to define. Like similar like in research, whatever is defining the problem. This is the first step. Understand and identify the data. So where from you are getting the data. If it is real-time data, historical data. If it is in proper shape, quality is good, quantity is good, everything you need to understand. What are the sources? Images, text, documents, spreadsheets, lot of sources can be there. Data structure types, warehouses, cloud, from where you are getting the data. Collect and prepare the data. After getting the data, you need to collect and prepare the data. You need to see if the data is standardized. Like statistically, you have to see, you need to remove the outliers and everything. Augment the data. If you need to augment the data, you can augment it, change certain things. Remove incorrect data. Need to check if there is some incorrect data, remove it. Remove duplicates. Lot of duplicates can be there. Delete the duplicates. Feature selection. Again, this will be taken care by the software of the computer. So what are the... सुनाई दे रहा है? Hello. Hello. So their important step is training. So training is basically finding the best parameters. So what are the steps in training? So we initialize with random values. Like I was showing y is equal to mx plus b or whatever is the function. We will set some random value. Start with the random values. Initialize them. Then we will expose the input and the outputs to the algorithm. We will expose our model. We will evaluate. Based on it, we will evaluate. We find the error. We see how much is the error. That is the third step. And the fourth step is to repeat the step 2 and 3. We will keep on repeating step 2 and 3. Keep on training the model, finding the parameters and evaluating it. We have to keep on continuously evaluating if the error is getting minimized or not. So this is called as training loop. So keep on training until you find a generalized solution and your validation losses are getting reduced. Until the validation losses keep on reducing, keep on training the model. Then hyperparameter tuning. You keep on tuning your hyperparameter, changing them and see what are the best fit parameters for your problem or your set of function. Again, optimization is the last step. So we need to optimize. We need to find the error. Like in linear regression, we will be using least square. Least square is taking the square of the errors, adding them, and taking the average values. Seeks to find, so this mean square error seeks to find the error of squared error of the expected values. Choose the values of constant such as the sum of same thing. We need to fit our model in such a way that the sum of square or the error term is as low as possible. The difference between expected and the predicted value is minimum. Error is minimum. So again, this is some important terms called as gradient descent. So the maths behind finding the optimum is called as gradient descent. You need to just understand these terms, not go deeper into the maths. Again, I will tell you this. All will be taken care by the computer. You can just line 2 lines of code and you'll be able to do this. So you need to define a learning rate. I will tell you what a learning rate is and what a gradient descent is. So you need to optimize the parameters such that the error is as reduced. You fine tune the model. So we have defined a function called a J function, which is a loss function. So loss function is squared error. Squared error. H of x is our predicted value. So h of x you can see here. H of x is our predicted, our model function is h of x, and the expected values are y. So difference between them and the square them and add them. The summation of all these terms divided by total number of terms. Basically the squared error is our j. We need to reduce the j. So you see here all these are squared. H of x minus y. So we're getting a squared function. Squared function is quadratic in nature. Quadratic function looks something like this. So quadratic function takes always a curve shape. And we need to reach the minimum value. This is the minimum. And gradient descent is basically taking a slope of the curve. We keep on taking slope of the curve and we have to reach the minima. So that is gradient descent. So you can see point number 1 or 2. So taking random values, you might reach 0.1 or 0.2. So the gradient descent is algorithm written in such a way that you keep on reaching to the minima. You keep on reaching based on your step, how much step you are using. So if you have reached 1, it will minus, so the slope is negative. So you will come to the lower values and reach the minima. If it is 2, it keep on adding and you will reach here. So basically our aim is to reach here. You can be here or you can be here. So gradient descent is basically reaching the minima is all you need to understand. No need to go into the deeper maths of this. So the gradient descent continues until you reach the minima based on your learning rate. Again a new term. So by how much value you are, how fast you are reaching the minima is called as learning rate. So just understand this, or you can just understand this two term, gradient descent and minima, and third term is learning rate. So you need to define these three things. Learning rate basically, based on the learning rate, how fast you converge to the minima, it depends on that. This is your hyperparameter. So how do you evaluate? Now you fit certain model, how do you evaluate it? So you need to understand what is loss. Loss we have already discussed. Accuracy, precision, recall, and area under the curve, ROC, AUC, you need to understand. So the model can be overfit. Overfit is like too much fitting to the data. It is not generalizing the function for us. It is underfitting. When the bias is too high, it can be underfitted. We need a good balance. Good low bias as well as low variance. This depends upon the complexity of the model. If the model is too complex, it will be overfitted. If it is too simple, it is underfitted. We need a good balance. So how do we do that? So this is how it looks, the curves. So validation is something which we test our training on. So if it is overfitted, the model will not generalize. It will give higher on validation set. We need an ideal scenario like the third one where the loss as well as the training loss as well as the validation loss both are decreasing. Second is both are not decreasing, that is underfit basically. So what if the model is underfitting? That means the model is not expressive enough of the data. You need to train for more time. Training set does not contain the desired information. Increase the capacity of your model. This is what the reasons and ways to overcome underfitting and overfitting. Overfitting, the features specific to the training set are not present in the validation set. So this can be the reason for overfitting. So there are a lot of things like you can do regularization. You need to penalize your loss function basically if it is overfitting. There are a lot of things like dropout, data augmentation. You can do this stuff to overcome underfitting. Then what are the challenges of machine learning in healthcare? So correlation versus causation. So there can be a lot of correlation may not be caused because of each other. Like during the summer time, a lot of people eat ice cream. A lot of people get sunburn. So if you see the graph of sunburn as well as ice cream, both see a peak during summer. So what the computer will tell, it will tell when because of increasing sunburn rays, the ice cream sales are increasing. So maybe they are not correlated to each other. No correlation between them is present. Causation, they are not caused because of each other, but they are giving a peak at the same time. So you need to understand the context. So medical context can only be understood by you people. That is why you need to understand and get into machine learning, because other people will not be able to understand the context of the problem and they will generalize whatever the computer shows. Computer does not understand the context. So model learns through association. Like it will see association of sunburns and ice creams. It will generalize and give some conclusion. So this causation, correlation, differentiation can only be understood by domain experts. So might get difficult to understand if the association are due to same thing again. So classical example is like US Army was training images of tankers, of Russian tankers and American tankers. So they tested it and it was performing excellently. It was categorizing the tanks as American tanks as American and Russian tanks as Russian. But when they tested it in real life scenarios, like we took it in the open, it was not able to study. Because what the model was seeing, like Russia, a lot of ice and snow was there. And in the US, the images did not contain ice and snow. So basically it was learning the weather. It was not learning on the tanks, images of tanks. So that is why these things can happen if a non-medical does studies and AI research in healthcare. That is why we need domain expert here. So what are the challenges of machine learning in healthcare? Class imbalance. Like the data needs to be equal. Like if you have, like I was telling about the tumor things, you need both term of data, like somebody having a tumor, benign tumor and malignant tumor. You need equal number of data for both the sets. Somebody is having heart attack or not attack based upon ECG. You need both data. Somebody who has undergone heart attack, someone ECGs that people have not undergone heart attack. So if it is unbalanced, again there will be bias in your model. Retrospective data and shelf life. Like a lot of clinical practices are changing every day. New medication are coming, new drugs are getting invented. So sometimes the data can be, the data can have a shelf life, can have an expiry date. So this can be an issue in medical healthcare sector. Lot of data is there which is being generated, but it is unlabeled data. People don't know the labels, or it needs to be done by medical expert. We have less people to do this stuff. Then when you go deeper into it, there are a lot of models which are very complicated and some are very simple. Like some are black box. You just give the input, you just get the output and it maps everything for you. This is like neural network and deep learning. We have not discussed them here. So they are not interpretable at all. This can be very dangerous in healthcare sector. We don't know how the model is working, how it is correlating the inputs to the outputs. Then this can be a dangerous thing. More simple the model, the easier it is to interpret, but the complex it gets, accuracy also increases, but you don't know how the model is working. Transparency is not there. So that is why we need multidisciplinary approach in healthcare. Again, I have emphasized the same thing. Challenges, again, I have told: workforce displacement, skill atrophy, algorithm and user bias, patient privacy, medical legal responsibility. You have to understand everything, oversight and regulation, quality of data. These are all issues in healthcare sector. This is all references I have given here, whatever references I have used. And what are the best online resources? You can use these resources. This is Coursera course by Stanford University, Machine Learning by Andrew Ng. The professor, he is like the pioneer of open source machine learning. So free course, you can use this, learn from this. Free online book by Ian Goodfellow, www.deeplearningbook.org. Again, he is a Stanford student. He has done a lot of pioneering work like Apple, Microsoft, everywhere, Google also. And you can Google stuff. Lot of literature you will find on Google. Thank you. That's all from my side.